Welcome to HB Tuner's Gen 2 Coyote Training Part 27. This training module, we're going to be taking a look at how to dial our speed density tables in for our truck applications. So if we don't have a mass airflow sensor fitted to our engine, which we have on the trucks, we need to go in and dial things in a bit differently when we cover in our previous training module for our Mustang applications. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at how to dial in the speed density tuning for our F150 truck applications. We'll find that we have a completely different calibration technique in order to dial our speed density tables in compared to our Mustang application. In fact, we'll find that the way the Mustang versus the truck deal with speed density is completely different because the trucks aren't fitted with a mass airflow sensor where the Mustangs actually have a mass airflow sensor. So the first thing I want to talk about here is the key differences between a truck and a Mustang application in terms of our airflow or air mass representation, which leads us back into our speed density that we're referring to here in this tutorial. So just let's recap our Mustang and then we'll talk about the differences with a truck and what we need to know about this. So on a Mustang, we know that we have the engine fitted with a mass airflow sensor that's registering the airflow or air mass coming into the engine at any given time. We have a hybrid type of situation because we have both a mass airflow sensor and we utilize speed density calculations on a Mustang to improve the transient conditions where we have large throttle change, bursts of airflow coming into the engine, where the mass airflow sensor isn't fast enough to detect that airflow burst. We fill in the gap, so to speak, using the calculated or inferred speed density air mass amount that's entering the engine, and that improves the drivability in a mass airflow car. We can determine what that speed density is going to be and calculate it what's going to be based on knowing what the map pressure change or rate of change is going to be over a given period of time. Now, on the Mustang applications, we don't have a map pressure sensor fitted to the engine. Ford engineers have decided to use something known as throttle mass flow to be able to determine what that map pressure reading is going to be at any given time. It's an inferred or a calculated amount. Now, they probably have done this for cost saving because if they don't have to fit a map pressure sensor to thousands or hundreds of thousands of vehicles, it's going to save a considerable amount of money in the production of the vehicle and make them more profitable. So in order to determine what that map pressure value is going to be, the calculated map pressure, they utilize throttle mass flow. Throttle mass flow is going to be assuming we know a whole bunch of variables. So we'd know what the amount of airflow is coming into our throttle plate. We'd know the pressure that's on the inlet side of our throttle plate, which is baro pressure. We'd know the effective area of our throttle plate. We're going to be specifying that with our throttle body data tables. We're going to be knowing what the throttle angle's at, the actual throttle opening in range of the throttle travel. And then lastly, we would be able to determine what the map pressure or the outlet side of the throttle plate is going to have in terms of a pressure vacuum reading. We can figure all of that out knowing, we can figure out any of those variables knowing we need at least a few of the variables to determine what that is going to be, that unknown variable. In the case of a Mustang, the map pressure sensor on the intake manifold side of things, so the outlet of the throttle plate, that's what we're not going to know. And that's what we use throttle mass flow to calculate that calculated map pressure reading. So we know flow in the throttle body from the mass airflow. We know the baro pressure, effective area, throttle angle opening. We can figure out the calculated map. By knowing the calculated map pressure, we fit that into a traditional speed density type of calculation, and then we can infer or estimate what the amount of airflow entering the engine is going to be. Now, what's a little bit confusing about the Mustangs, definitely a little bit unique, is that the calculated map pressure is a function of the mass airflow sensor curve or how much airflow is coming into the engine. The baro pressure is going to be relatively fixed, effective area is going to be fixed, throttle angle open does vary, but we'll find the mass airflow sensor is going to influence heavily what the calculated map's going to be, and then influence heavily what the inferred air mass or calculated air mass coming into the engine is going to be. So everything really hinges upon the mass airflow sensor on our Mustang applications. Now, when we're talking about our truck applications, that is not going to be the case. We don't have a mass airflow sensor, so we can't measure how much airflow is coming into our engine in that throttle mass flow type of situation. So in order to determine what the airflow entering the engine is going to be, we need to solve for that unknown amount of air mass.
and that's going to be where we use throttle mass flow to fill in the blanks. So on a truck application, we do have a map pressure sensor fitted to our intake plenum, so we're going to know what the vacuum or pressure is going to be after the throttle plate at any given time.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.